Okay, class. Let's see. Can y'all hear me? Can anybody hear me? All right, rock and roll. Thank you. All right, here's the exam from last time. Let's make ourselves some room here. All right, if this is bothering you, all right, we're gonna get this done. This here, you could think of this as the letter K. It's just a number. X is a number, Y is a number, 2 is a number, and X plus Y plus 2 is just a number. What we want to do is we want to take 2x and we want to multiply it by that number. And we want to take 3y and also multiply it by that number. And we want to take 1 and multiply it by this number. Okay. Now we're almost there. Now we want to do what we just did to this. We need to take this 2x and multiply it by the x. And we want to take the 2x and multiply it by the y. And we want to take the 2x and multiply it by the 2. Okay. Let's squish this a little bit. Now we want to do the same here. We want to take the 3y and multiply it by the x. We need to multiply the 3y by the y. We need to multiply the 3y by the 2. And we need to take 1 times the x, a 1 times the y, and a 1 times the 2. Now we can multiply these out. This is 2x squared. This is 2xy. 2 times 2 is 4. Here we write this as 3xy. We put them in order. It helps us combine like terms later, like when we're trying to compare those. Okay, that's our 3xy. We have our 3y squared. 3 and 2 makes 6. We have an x and a y and a 2. Now we want to combine like terms. Here's an x squared. There are no other x squareds. Here's an xy. Here's also an xy. We have 2 and 3 give us 5xy's. Here's 4 x's and another x. It gives us 5 x's. Now we have a y squared. There's no other y squareds. Okay, that one's taken care of. Here's 6y and another y. Give us 7 y's. And then all that's left is 2. We've combined all our like terms. We multiplied it out and combined all our like terms. Notice there was 3 things here and 3 things here. When we multiplied them, we got 1, 2, 3, 4, 5, 6, 7, 8, 9 things. Okay. After that, we combined the like terms and we ended up with what? 6. All right, let's look at another one. This one's not going to be as long as the last one. There's 2 terms here and 3 terms there, so we're going to get 6 terms all in all. First, we have this 3x squared here that we're multiplying by this number. And we have a y squared that we're also multiplying by this number, right? This is the same thing as if we took a plus b times c, where this is a, this is b, and this is c, right? You would have an a times a c and a b times a c. That's all this is. Here's the a, here's the b, and that's c. Okay, it's the same thing. So now we need to expand these. We have of 3x squared times each of these three things. We have a 3x squared times a 2x. We have a 3x squared times 3y. We have a 3x squared times the 1. Now for this one over here, we have y squared times the 2x. We have y squared times the 3y. And we have y squared times the 1. So here we'd have 3 times 2 is 6. And then we have x squared times x gives us x cubed. 3 times 3 is 9. We have x squared y. Here 3 times 1 is just 3. And we have x squared. Here we have 2x y squared. This one we have a 3. Y squared times y gives us y cubed. And then y squared times 1 is just y squared. Now we can look to combine like terms. Here's an x cubed. There's no other x cubes. Here's an x squared y. There's no other x squared y's. Here's an x squared. There's no other x squareds other than this one, but you can't combine these. This one doesn't have a y and this one does. It has to have the same letters and the same exponents for you to be able to combine them. So you cannot combine these, even though they both have x squared, again, because this one does not have a y. Here we have an x squared. There's no other xy squareds. We have a y cubed. There's no other y cubes. And a y squared. There's no other y squared. So we can't, there's no like terms to combine. So that is our final answer. Okay. Now this distribution thing is what gets most students. This is the basics of algebra. You have to get this distribution stuff down. And here soon you'll be able to go straight from this step to this step. Okay, you'll be able to just write them down. 2x times x is x squared. 2x times y is a 2xy. 2x times 2 is a 4x. 3y times an x. 3y times a y. 3y times a 2. 1 times x. 1 times y. And a 1 times 2 down here. So here, soon you'll be able to go straight to that step. All right, let's have a quiz. Daily quiz number 19. Multiply. All right, just like we did. All right, let's do x plus y plus z times 2x squared y plus 3xy squared plus 4z. And here let's do an a plus a b plus a c times x plus y plus z. No, let's not do that. Let's do, you won't have any like terms. I want you to have some like terms to combine. Let's try this again. Let's do 2xy plus 3yz plus 4xz times 4xy plus 2yz plus 3 xz. Let's see if that gives us some like terms. All right, I should be able to do these in, I'd say 10 minutes. If you know what you're doing, again, you take this times that plus this times that plus this times that. It's your first step, the distributive property. All right, be sure to help one another out. For those of y'all who still find this extremely confusing, all right, if you know this stuff well, help your classmates out here. So put you in your breakout rooms. Let it go. All right, class, let's multiply these things out. Let me squish this a little bit. What we have here is we have an x times this big pile of stuff. And we have a y times this big pile of stuff. And we have a z times the big pile of stuff. Right? This times this, plus this times this, plus this times this. Right? The x, the y, and the z all times the same big pile of stuff. So we have an x times this, times that, and times that. So we have an x times a 2x squared y. We have an x times a 3xy squared. Weird looking y. And we have an x times a 4z. All right, that's this part. Now we have a y times 2x squared y. And we have a y times a 3xy squared. And we have a y times a 4z. We'll smash that. Now the last term, we have a z times 2x squared y. And we have a z times 3xy squared. And we have a z times a 4z. So this term, the 2x and x squared gives us x cubed and a y. Here we have a 3, x and x gives us x squared, and we have a y squared. Here we have a 4, x and a z. Here we have a 2, an x squared, y times y is y squared. Here we have a 3, an x, y times y squared is y cubed. Here we have a 4, a y, and a z. Here we have a 2, an x squared, a y, and a z. Here we have 3, an x, a y squared, and a z. And we have a 4 and a z times a z squared. Let's see if we can combine any of this stuff. All right, here's an x cubed y. Are there any x cubed y's anywhere? No. So we can't combine that with anything. All right, so that's taken care of. X squared y squareds. Are there any? Here's one. Any other x squared y squareds? No. So 3 and 2 make 5 x squared y squareds. Here's an xz. Any other xz's? Xz, xz. Here's an xz, but it has a y squared in it, so we can't combine that. So this xz is by itself. This has already been taken care of. Xy cubed. Any other xy cubed? No. So it's by itself. A yz. Any other yz's? No. So it's by itself. X squared yz. Any other x squared yz's? No. XYZ squared, and XY squared Z's? No. And then a 4Z squared. That's as far as we can simplify it. All right, any questions about that one? Same trick here. We have a 2xy. Let's crush this thing a little bit. We have the first thing times the pile of stuff. Then we have the second thing times the pile of stuff. And then we have the last thing times the pile of stuff. We have the 2xy times the 4xy. We have the 2xy times the 2yz. We have the 2xy times the 3xz. So there's that thing multiplied out. All right, we went that times that times that, and that times that. Let's smash this. Now we have this term. We need this times this times this, and this times this. Let's write it out. The 3yz times the 4xy. We have the 3yz times the 2yz. And then we have the 3yz times the 3xz. Running out of room, right? Here we need this times this times this, and this times this. So we have the 4xz times the 4xy. We have the 4xz times the 2yz. We ran out of room. Let's smash this even further. And we have the 4xz times the 3. Make more room. Times the 3xz. All right, let's see if we can read this now. 2 times 4 is 8. We have an x times an x is x squared. A y times a y is y squared. Here we have a 2 times a 2, which is 4. We have an x, a y times a y, and a z. 2 times 3 is 6. X times x is x squared, and a y and a z. 3 times 4 is 12. There's an x, a y times a y, and a z. Here we have 3 times 2 is 6. There are no x's. We have a y times a y, and a z times a z. Now here we have a 3 times a 3 is a 9. There's one x, there's one y, and a z times a z. Here we have 4 times 4 is 16. There's an x times an x. There's a y, and there's a z. Let's make some room. So that was this one, right? X squared, y, z, yeah. Here we have a 4 times a 2 is 8. There's a single x, a single y, and a z times a z. And now the last term. 4 times 3 is 12. There's an x times an x, no y's, and we have a z times a z. And now let's see if we can combine any terms here. We have an x squared, y squared. Any other x squared, y squared? No. How about this one? X, y squared, z. X, yeah, we do have one. Oh, I need to write this down. We have x squared, x, y squared, z. Where is it? X, y squared, z. Any other x, y squared, z's? No. We have 4 and 12, which gives us 16 x, y squared, z's. Here we go, x squared, y, z. Any x squared, y, z's? Here's one. So we need 6 and 16 gives us 22 x squared, y, z's. Okay. Here we have y squared, z squareds. There are no other. How about an x, y, z squared? There's 9 of them. X, y, z. Here's another 8. 9 and 8 make 17 x, y, z squareds. And then we have left over 12 x squared, z squared. All right, even if you know what you're doing, it's easy to make a mistake, so you have to be careful. But with practice, you get to where you can do this basically without thinking and not make an error. Okay. And since y'all are STEM students, y'all are going to be doing this kind of stuff every day for the rest of your lives. So, any questions? Most of y'all did pretty good on the exam. Some of y'all, I could tell you knew what you're doing, but you made like a small mistake, and it got out of whack. It's basically accounting. And a couple of y'all had no clue. Right? If you have no clue, hopefully this quiz has helped. Otherwise, hit the tutoring lab. That's what they have it for. They have 2 of them. Take advantage of that. Last time we were in 13.7, I think. Yeah, we're in 13.7. So you can see here all the sections for which we've done that you need to have done the ALEKS homework. Okay. 13.7, we did example 2. Yep. So these can be confusing. We are dividing here. All right. What we're doing is we're taking 3x squared plus 2x minus 5, and we're dividing x plus 2 into it. And we do it the same way that we do long division with numbers, right? We're dividing x plus 2 into 3x squared plus 2x minus 5. Okay, so just like when you're dividing like 15 into what? I'll do 175, right? We need to pick a number here. Like in this case, we pick 1, because 1 times 15 is 15, and then we subtract, right? Because we're trying to get as close as we can to 17 without going over, right? Same thing over here. We need to get a 3x squared. What do we need to multiply x by to get a 3x squared? We need to multiply it by 3x. Now, instead of writing it here, I'm going to write it over here so it's in the x column. It's just nicer that way. So, but if I multiply this thing by 3x, yes, I get a 3x squared, but I also get a 6x. Okay. So if I subtract these, 3x squared minus 3x squared, those cancel. That was the goal. But now we have a 2x minus 6x, which gives us negative 4x. And then we'll bring down our minus 5, just like we used to bring down the 5 here. Okay. So now we're aiming for this. Just like at this point, we'd be aiming for 25, and in this case, we do a 1 again, because 1 times 15 would be 15. We'd subtract. Over here, we're aiming at this. We got to get rid of that now. That's what's left over, the minus 4x. So if I multiply the x by a minus 4, I will get a minus 4x, but I'll also get a minus 8. If I subtract these, negative 4x plus 4x, those go away. Now I have a minus 5 plus 8, which will give me a positive 3. And there's nothing I can multiply to give me that 3, right? Just like over here, we have a remainder of 10, right? So 15 goes in the 175 11 times with a remainder of 10. So we would say plus 10/15, all right? Because it doesn't go in a whole number of times. All right, it'd be this over this. So over here, we would say it's 3x. This is equal to 3x plus 4, minus 4, plus 3 over an x plus 2. Okay? And you can check your work. Let's get all this out of the way. So let's check our work. Does this equal? Well, if you multiply both sides by x plus 2, that cancels. We'd be like, okay, it's 3x squared plus 2x minus 5 equal to this over here. Well, we have this thing times this thing, and we have this thing times this thing. Well, the x over 2 and the x over 2 would cancel, so this is just plus 3 here, okay? That's just 3. So are these the same? Well, if we multiply this out, we have 3x squared, a 6x, a minus 4x, a minus 8, and a plus 3. This is 3x squared plus 2x minus 5. These are the same thing. So yeah, it worked out correctly. Okay. You can always check your work on these.
In this video, we'll divide 5y squared plus 2y cubed minus 1 by the quantity 2y plus 1. Since the divisor has more than one term, I'll use long division. When I set up the long division, I'm going to write the dividend in descending order and leave space for missing powers of y. We have 2y cubed plus 5y squared plus 0y minus 1, all divided by 2y plus 1. I need to multiply 2y by y squared to make 2y cubed. Now, y squared times 2y is 2y cubed, and y squared times 1 is y squared. I'll draw a line and subtract. And to subtract, I'll have the opposite of each term by changing the signs and adding. Combining like terms, we have 4y squared. Then I'll bring down the next column. At this point, I need to multiply 2y by 2y to make 4y squared. So 2y times 2y is 4y squared, and 2y times 1 is 2y. I'll draw a line and subtract, and I'll do this by changing the signs and adding the opposite. Adding like terms, I have negative 2y, and I'll bring down the next column. Now I need to multiply 2y times negative 1 to make negative 2y. So negative 1 times 2y is negative 2y, and negative 1 times 1 is negative 1. I'll draw a line and subtract. Combining like terms, you see that the remainder is 0. So the quotient is y squared plus 2y minus 1.
All right, let's see. On page 807, we're dividing 3w minus 1 into 3w cubed plus 26w squared minus 3. So in order to get a 3w cubed, I need to multiply this thing by a w squared. I'll put it over here in the w squared column. So w squared times a 3w gives me my 3w cubed, right? All right. But I also get a minus w squared. Now we subtract these. These, of course, cancel. 26 minus a negative is a plus. That gives me 27w squareds. Now, what do I multiply this by to get a 27w squared? Well, if I multiply it by a 9w, 9 times 3 is 27, w times w is w squared, and that's awesome. But I also get a negative 9w out of it. And you know what? I totally forgot. I forgot to bring down my minus 3 here. Yeah. Yeah, I forgot to bring down my minus 3. So now when we subtract, this is awkward, right? Things aren't lining up at all. What we need here is to fix our columns. There is no w, right? Notice this isn't lining up. One has a w, the other one doesn't. What you can do here is put 0w. That's what really needed to come down. 0w. Okay? So you want all the powers of w here. So bring that down. Now we subtract. Those cancel out like we wanted. 0 minus a negative is positive 9w. Then bring down our minus 3. So now we need to get a 9w from a 3w, which means we need a 3. 3 times 3w gives us our 9w, but we also get a minus 3 out of it. If we subtract these, those cancel. Minus 3 plus 3 gives us 0. So this is our answer. There's no remainder. It factors in completely. All right, and you can check your work. They're saying 3w cubed plus 26w squared minus 3 divided by 3 minus w. We're saying that this is equal to w squared plus 9w plus 3. Did we do it right? Well, if we multiply both sides by 3w minus 1, that and that cancel. So is this times this equal to that? Let's find out. We have w squared times 3w is 3w cubed. We got a w squared times a minus 1. 9w times a 3w gives me 27w squareds. 9w times a minus 1. A 3 times a 3w. And a 3 times a minus 1. We have a 3w cubed. These are like terms. We have 26. These cancel, and then a minus 3, and this is the same as that. So they are equal. And we did it right. Look at another example. We want to divide a 3x plus 2 into 9x cubed plus 11x plus 10. All right, notice there's no x squareds here. So in order for our little columns and stuff to work out, we need to put 0x squareds in here so that we have everything we need. So to get a 9x cubed from 3x, we need to multiply it by 3x squared. 3 times 3 is 9. X squared times x is x cubed. But we also get a 6x squared out of it. When we subtract, those went away like we wanted, but we're left with a negative 6x squared. We'll bring down our 11x here. So now we need to get this out of that. I need to multiply 3x by a negative 2x. Negative 2 times 3 is negative 6, and the x times an x gives me x squared. But I'm also getting a negative 4x out of this. If I subtract, those cancel. 11x plus 4x gives me 15 x's. Bring down the 10. I need a 15x from a 3x. I need to multiply 3x times 5. That gives me my 15x. And it also gives me a plus 10. I subtract these, I get 0. That is my final answer. All right. This is 3x squared minus 2x plus 5. And you can check your work by multiplying both sides by 3x plus 2. 3x plus 2 over 3x plus 2 goes away. Is this equal to that? Multiply it out to find out. 3 times 3 is 9. X squared times x is x cubed. 3x squared times 2x gives us 6x squared. Now for this term, negative 2x times 3x, negative 6x squared. Negative 2x times 2. Now 5 times 3x is 15x, and then 5 times 2 is 10. We've got these x cubes, those cancel. 11 minus 4, 15 minus 4 is 11. And this is the same as that, so we know we did it right.
In this video, we'll use long division to divide y cubed minus 5y squared plus 3y minus 15 by y squared plus 3. I'll set up the long division. And notice in this case that we don't have a missing power in the dividend. But we do have a missing power in the divisor. I'll use a placeholder of 0y in the divisor. Next, what do I need to multiply y squared by to make y cubed? I need a factor of y. So I'll write y in the quotient. Multiplying y by the divisor gives me y cubed plus 0y squared plus 3y. To subtract, I'll take the opposite of each term and add. We have negative 5y squared plus 0y minus 15. So now, what do I have to multiply y squared by to make negative 5y squared? We need to multiply by negative 5. So I'll add negative 5 in the quotient. Multiplying the divisor, y squared plus 3, by negative 5 gives us negative 5y squared plus 0y minus 15. I'll draw the line, change the signs, and then add. This gives us a remainder of 0. If we multiply the divisor, y squared plus 3, by the quotient y minus 5, and add a 0 remainder, we should get the dividend. Y squared times y is y cubed. Y squared times negative 5 is negative 5y squared. 3 times y is 3y. And 3 times negative 5 is negative 15. Adding 0 doesn't change anything, and we see that this product equals the original dividend. I want to make one last comment about getting a remainder of 0. When this happens, it means the divisor divided evenly into the dividend. That means the divisor must be a factor of the dividend, and the quotient is the other factor. The polynomials y squared plus 3 and y minus 5 are factors of the original dividend.
All right. Let's see. let's see here. We're gonna divide these. We kind of want to put them in order. We'd want to put y squared plus 1, and then put these in order from least to greatest. We have a y to the fourth. There's no y cubed, so we'd want to make a space for it, though. There's no y squareds. You want to make space for those. Then we have our 2y, and we have our minus 5. Okay, so you want to put them in descending order. So to get a y to the fourth from a y squared, we need to multiply it by a y squared. We'll put it over here in the y squared column. Y squared times y squared is y to the fourth. Let's see, what am I doing here? Bring down 0y cubed. No, we don't do that yet. Hold on. We get the y to the fourth, but we also get the y squared. There we go. Now we want to subtract these. And let's see, how can I do this? We have to put the y squared over here. Okay, we didn't get any y cubes. All right, so let's subtract these. Those cancel like we wanted, but we're also getting a negative y squared left over. Negative y squared. Then we can bring down our 2y. We need a negative y squared from a y squared. So we need to multiply it by negative 1. So I'll put over here where there's no y's. Negative 1 times y squared gives me a negative y squared. Negative 1 times 1 is a minus 1. And we need to subtract these. Negative y squared plus y squared cancels like we wanted. And this is in the wrong column. I need to put it over here, but there's no y's. So I got a 2y minus no y's. So that gives me 2 y's. And then I have, oh, fucked up. Hold on. I need to bring down my minus 5 here too. Minus 5 plus 1 gives me a minus 4. At this point, we can't get a 2y from y squared. There's nothing you can multiply y squared by to get 2y. Okay, so at this point we're done. This is our remainder. So what we're saying here is that this is equal to y squared minus 1 plus this divided by this. All right, that's what you do with your remainder, remember? So we can check our work. Is 2, let me write them in descending order. Y to the fourth plus 2y minus 5 divided by y squared plus 1. Is this equal to y squared minus 1 plus 2y minus 4 over y squared plus 1? All right, we want to check, are these equal? Check our work. So what we do is get rid of the fractions. Multiply both sides by y squared plus 1. On the left-hand side, those go away. So what I have here is a y to the fourth plus 2y minus 5. And over here, I'm going to put some parentheses in here just for fun. This times this, we have y squared minus 1 times y squared plus 1. Plus this times this, in which case those would just cancel and you're just left with a 2y minus 4. So we can multiply these out because we're trying to compare it to this over here. There's no parentheses. So here we'd have a y to the fourth plus a y squared minus y squared minus 1, and then our 2y minus 4. Those cancel out. I have a y to the fourth, I have a 2y, and a minus 1 and a minus 4 gives me minus 5. So it is correct. They are the same. when they give you these things like this, you saw how they got clumsy, right? Trying to keep track of stuff because there's no y cubes and no y squareds, and then in this one there's no y's. There's y squareds and constants. So that's as complicated as this is going to get. But if you work with it, just try to use your common sense each step of the way. You should be able to pull it off. Let's do another one here. So we have an x squared and a 2. Put them in descending order. Here we have an x cubed, a minus an x squared. We need to put an x spot, so we go put 0 x's and then a plus a 4. All right, so we need to get an x cubed out of x squared. In order to do that, we need to multiply x squared by an x. And actually, we want to put over here in our x column. But out of that, we not only get the x cubed, we're also getting a 2x, which I need to put over here in the x column, okay? And when we subtract x cubed minus x cubed, that goes away. I have a negative x squared minus no x squared, so it leaves me with a negative x squared. 0 x's minus 2 x's gives me negative 2 x's. And I'll bring down the 4, right? So in order to get a negative x squared from x squared, I need to multiply it by minus 1. That gives me negative x squared. But I also get a negative 2 out of it, which I have to put over here where there's no x's, and then subtract. Negative x squared plus x squared is 0. That's what we wanted. Here we still got a negative 2x, right? Because there's 0 x's here. 4 minus a negative 2 is 6. At this point, there's nothing you can multiply. You can't multiply x squared by anything to get a 2x, right? There's not enough x's left. So that's the remainder. So we would say this is equal to x minus 1 plus the remainder divided by this guy. Okay? So we're saying x cubed minus x squared plus 4, this thing divided by x squared plus 2 is equal to this. We want to check our work here. Let's get rid of the fractions. Let me move this down a little bit. We have the same thing on the bottom here, so let's multiply both sides by x squared plus 2. Over here, that goes away. So we have x cubed minus x to the 4th plus 4. Is this equal to this stuff? Well, if I throw some parentheses in here, I have this thing times this thing. I have x minus 1 times x squared plus 2 plus this thing times this thing. And they have the same thing on the top and the bottom, so it could just be like that. You're just left with a negative 2x plus 6. Okay? But this over here, there's no parentheses, so let's multiply this thing out. We have an x times an x is an x cubed. An x times a 2 is a 2x. A minus x squared and a minus 2. Another minus 2x and a 6. We got x cubed here, a minus x squared. 2x minus 2x goes away. A minus 2 and a 6 gives us 4. And that is the same as the other side. We know we got it right.
In this video, we have to determine a correct procedure to divide the polynomials. In the first example, we have 3x squared plus 5x minus 8, all divided by the quantity x plus 2. Since the divisor has more than one term, we'll use long division. I need to multiply x by 3x to get 3x squared. So 3x times x is 3x squared, and 3x times 2 is 6x. I'll draw a line and subtract by adding the opposite. Combining like terms, we get negative x. I'll bring down the next column, and I need to multiply x by negative 1 to get negative x. So negative 1 times x is negative x, and negative 1 times 2 is negative 2. I'll draw the line and change the sign, and we have a remainder of negative 6. So the answer is 3x minus 1 plus negative 6 over x plus 2. In the second example, we have x cubed plus 24x squared minus 8x, all divided by 8x. Since the divisor has only one term, I'll divide 8x into each term in the numerator. We have x cubed over 8x plus 24x squared over 8x minus 8x over 8x. This simplifies as x squared over 8 plus 3x minus 1.
Okay, so when do you use long division and when don't you? All right, so let's look at these. All right, it looks like we need to do long division for all of these. They just had an example. What if I had something like this? 2p to the 5th plus 3p to the 4th plus 7p squared all over p squared. All right, you don't have to do long division here. Here's an example. Right, this is 2p to the 5th over p squared plus 3p to the 4th over p squared plus 7p squared over p squared. Right, you're just dividing the p squared out of everything. So you would have 2p cubed, 3p squared, and 7. That's the answer, right? Look at this thing a little more clearly. Everything has at least a p squared in it. So you're just taking a p squared out of each one of these things, right? So you don't need to do long division. Here, this would be 2p to the 5th over p squared minus 2p plus 1. And then minus 8p to the 4th divided by the same stuff. And then the 4p here divided by the same stuff. And then a minus 16 divided by the same stuff. That's not really helpful, right? This big old pile of stuff, that's not helpful at all, right? Whereas up here, we could just write down our answer, right? So this, you'd need to do long division to do this one. This guy here, what would this be? You would have 2p to the 5th over 2p squared. The 2's would cancel, and you're left with a p cubed, right? Then here, the minus 8 divided by the 2 would give you a minus 4. P fourth over p squared gives me a p squared. 4 over 2 is 2. and then I'd have a p on the bottom. And then 16 divided by 2 would be 8, and I have p squared on the bottom. Right, I could just do that. That's helpful. If I wanted to, I could combine those. If I wanted to do p cubed minus 4p squared. This thing I could write, multiply the top and the bottom by a p. So I would have 2p minus 8 both over p squared. All right, so long division wasn't required for that. It's because there wasn't a whole bunch of stuff down here. If there's only one term, right? There's only one term here. Let's put it over here. 15z cubed. The z cubed over z cubed goes away. 3 over 15 gives me what? 1/5. 3 over 15. Now here I have a negative. 5 over 15 is 1/3. And there's one extra z on the bottom than on top. So I would have a z on the bottom. Then here, 10 over 15 is 2/3. And there's z cubed on the bottom. Okay. And if I wanted to write these as one thing, one big fraction, I could multiply this by z cubed over z cubed. If I multiply this by z squared over z squared, now I have the z cubed on the bottom. But I'd also need a common denominator, right? I'd have to multiply this thing by a 3 over 3 and these by a 5 over 5. But if I did that, I'd end up exactly with what I started off with. Right? So we'd leave it like this, okay? If you try to combine these, you just end up with that again. All right, but we didn't have to do long division. We just divided this thing by each one of these things separately. Here we need to use long division because this isn't just one thing, it's two things, right? I could write this as 3z cubed over 3z plus 1, and then a minus 5z squared over 3z plus 1, and then plus a 10 over 3z plus 1. I could do that, you know, but I'm not getting like the answer that they're looking for. I mean, these things are definitely equal, right? Like this up here, these are definitely equal. It's the same thing. But this form isn't very useful, right? They'd want you to do the long division. Yeah, that one they just wanted us to determine whether it was necessary. Here they want us to actually divide. So here they don't tell us what the appropriate method is. I can tell you right now, because there's more than one thing on the bottom, we need to do long division. We're doing 2x plus 3 into 6x cubed minus x squared plus 3x minus 5. Okay. And on the bottom we have, sorry. So we need to get a 6x cubed from a 2x. So we can multiply it by 3x squared, and we put that in the x squared column. So 3 times 2 is 6. X squared times x is x cubed. We're also getting a 9x squared out of this. Those would cancel. Negative 1 minus 9 gives me negative 10x squared. Bring down the 3x. To get a negative 10x squared from a 2x, we need to multiply it by a minus 5x. Minus 5x times 2x is negative 10x squared. We're also getting a negative 15x out of this. If we subtract, 3x plus 15x is 18x. Bring down the minus 5. To get the 18x from 2x, we need to multiply it by a 9. 9 times 2 is 18. We're also getting 9 times 3, which is 27. So when we subtract these, minus 5 minus 27 is a negative 32. So this thing is going to equal this stuff plus negative 32 over 2x plus 3. All right, that's our remainder term. Look at the second one here. So this guy here, there's only one term. So we got 9w cubed over 3w. We have an 18w squared over 3w. We have a 6w over 3w, and we have a 12 over 3w. 9 over 3 is 3. W cubed over w is w squared. 18 divided by 3 is 6. We have an extra w on top. 6 over 3 is 2. The w's cancel. 12 over 3 is 4. And we have a w on the bottom. So we don't have to use long division there. These up here, the ones where they gave you stuff like this, where you're dividing, but there was no x, it might be easier for y'all if you put in like a 0x there. All right, that might help you out as far as doing this stuff. Synthetic division. I don't know if I ever learned this. Let's see. All right, this only works. It can only be used when dividing a polynomial by a first degree divisor of the form x minus r, where r is a constant. It's called a shortcut because it uses the coefficients of the divisor and dividend without writing the variables. I'm not going to waste my time with this because there's a whole bunch of stuff to memorize, and it only works in one special case. And the reason why it works out isn't that clear. All right. As long as you can do long division, you can divide it. All right. So this synthetic division only works if you have something of the form x minus a number. That's the only time that it works. We can watch their video, I guess, but so like this one here, you would write it as y minus negative 2. All right. I don't want to spend too much time on this. But I guess it will be in the Alex homework though, won't it? So I guess we have to cover it.
In this video, I have to divide 4x cubed plus 7x squared minus 3 by the quantity x minus 2. This is the same example that I did in an earlier video using the long division process. However, in this video, I'm going to use sort of a shortcut method called synthetic division. The first thing to note is that to use synthetic division, the divisor must be in the form x minus some number r. In other words, the divisor must be a linear expression, that is, x is to the first power only, and the coefficient on x must be 1. To start, the divisor is x minus 2, which is in the form x minus r, where r is 2. I'm going to draw sort of a half box here on the left and insert the value of r. Then to the right, I'm going to write the coefficients of the dividend, including placeholders for any missing powers of x. So I have 4, then 7, then 0 as a placeholder for 0x, and negative 3. Next, I'll skip a line and draw a horizontal line below. At this point, I'm going to bring down the coefficient of the leading term and write this coefficient below the horizontal line. And here, I'm going to take the product of this number below the line times the value in the box. This gives me 2 times 4, which is 8, and I'll write this result in the next column just above the horizontal line. Then I'll add the numbers in this column and write the sum, which is 15, below the line. I'll repeat this process through the last column of digits. I have 2 times 15, which is 30. I'll write 30 above the line. I'll add 0 plus 30 to get 30, which I write below the line. Then 2 times 30 equals 60, which I write above the line in the next column. The sum in the last column is 57, and I'm going to draw a box around this last number below the line. To interpret our results, I'm going to look at the numbers below the line. The last number on the right, that's the number in the box, is always the remainder. Then, moving from right to left, we have the coefficients of the quotient in increasing powers of x. So the number 30 is the constant term of the quotient. The number 15 is the coefficient for the x term. And the number 4 is the coefficient for the x squared term. The answer is a quotient of 4x squared plus 15x plus 30 plus 57 over the divisor x minus 2. This is the same answer we got in an earlier video using long division. At this point, you may be able to see that the pattern of numbers here in the synthetic division mirrors the pattern of numbers in the long division. Synthetic division is essentially performing the same algorithm as long division, but the variables are left off, and this makes the process shorter.
All right, so let's see if we can do one of these. Y'all are gonna have to remind me the steps. I don't like this because it doesn't, there's nothing to learn in it, just a bunch of steps to memorize that gives you an answer without understanding why it gives you the answer, really. So what we'd have to do is we'd have to write this x plus 3 as x minus negative 3. So our r is minus 3. And then I forget what they did. They did something like this. And we have to write our coefficients. Now they mixed them all up. So we have to have a 4 for the x cubed. No, wait, there's an x to the 4th here. So we have a 1, x to the 4th, 4x cubed. There's no x squared. There's 5 x's, and then we have a minus 6. And let's see if I can remember. What did they do? They brought down the first number, and then they multiply these. No, I don't remember. Who remembers the steps? Let me put them down here. No, I don't remember. Yeah, I've never ever used this because you can always do long division. And I'm not about memorizing a whole bunch of steps that I never use just for one purpose that I already know how to do another way. So we're not going to do synthetic division. This sucks. It's like FOIL, right? It's an algorithm that gives you an answer, but doesn't give you any insight in the math. So we're skipping this part because it's just stupid. If you have to divide these, just use long division, all right? If you're going to memorize some kind of algorithm, just pick one that does it for everything. Okay, so that's it for 13.7. So get your Alex homework done on there. And now we're skipping to 14.1. 14.1. Identifying the greatest common factor. What happened here? There we go. So we're trying to factor. All right, we can multiply polynomials. We're trying to do factoring. So you've learned how to multiply things like this to get this. You want to be able to do that well enough so that we want to be able to look at this and produce this. We want to go from a product to a sum, and we need to be able to go from a sum to a product. All right. So if you look at this, it's really hard to figure out that this thing is actually that times that. It's real easy to multiply these together to get that, okay? So first off, we need to know about GCF, greatest common factors, all right? Which, with just numbers, it's not a big deal. Let's look at this. Greatest common factor. It's asking what is the biggest number that divides into both these numbers, right? If you think about it, you might say, oh, the GCF is obviously 12, because 12 divides into 24, 12 divides into 36, and there's not a bigger number that's going to divide into both of them, because 12 is already half of 24. All right. Now you start getting stuff like this, you might be like, maybe 5, but what about like 15 or something? It gets kind of confusing. So the easiest way to do this is to do the prime decomposition. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. All right, so we'd say, okay, they both have a 2. They both have a 2. And they both have a 3. That's what they have in common. Okay, 2 times 2 is 4 times 3 is 12. That's how you would do it. So for this one, we would do the 40, the 60, and the 105. Now you might look at it and think, I know 5 goes into everything, but is that the biggest number, the biggest common factor? Let's look at it. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. 105 is what? 5 times 21, right? Because 5 times 20 is 100. So it's 5 times 21. 21 is 3 times 7. So we'd have, they all have a 5. So the GCF is going to be 5. And that's it. Right? They all, two of them have a 3, but this one doesn't. So that the 5 is the only thing that is in all of these. Okay, so the GCF would be 5 for that one. So first we're going to deal with integers, and then we're going to move up to dealing with polynomials.
In this video, we want to find the greatest common factor, or GCF, for the numbers 20, 24, and 100. Well, as the name suggests, common factor means that we're looking for a number that divides evenly into all 3 values. To find the greatest common factor, it makes sense to factor each individual number and look for the greatest number that divides evenly into all 3 values. The number 20 equals 2 times 2 times 5. And I'm also going to write this using exponents. So 20 equals 2 squared times 5. The number 24 is 2 times 2 times 2 times 3. Or 2 cubed times 3. I'll factor 100 over here with factor tree. I can break down 100 as 10 times 10, and its further factors as 2 times 5 times 2 times 5. So 100 equals 2 times 2 times 5 times 5. Or simply 2 squared times 5 squared. Now to find the greatest common factor, let me circle all the factors that appear in all three listings. So 2 factors of 2 are common to all three listings. And that's it. So the greatest common factor is 2 squared, which is 4. Now another way to find the GCF is to write the product of common prime factors, with each factor raised to the lowest exponent which it appears. So in this example, the only common prime factor is 2, and the smallest exponent to which it appears is the second power. So 2 to the second power is the GCF.
And another example here. $12 and 20. 12 is 2 times 6, which is 2 times 3. 20 is 2 times 10, which is 2 times 5. So we both have a 2, and they both have a 2. So the GCF is 2 times 2 is 4. That's the biggest number that will divide both of these. We got a 30, a 45, and a 75. All right, 30 is 2 times 15. 15 is 3 times 5. 45 is what? 9 times 5. 9 times 5. 75 is what? 5 times 15. Right? Because 20 times 5 would be 100. Yeah, and 15 is 3 times 5. So our GCF here is going to have a 5 in it and a 3 in it, which gives us 15. Next step is throw some X's in there, of course, right?
In this video, we're going to practice identifying the greatest common factor among several terms in a polynomial. The greatest common factor of a polynomial, or GCF, is the greatest factor that divides evenly into each term. In the first example, we have the polynomial 20x to the fifth minus 8x to the fourth plus 12x squared. The GCF is 4x squared. The short explanation is that 4 is the greatest number that divides evenly into 20, 8, and 12. And x squared is common to all three terms. Now we can't use a higher power of x in the GCF because the third term of the polynomial is limited to x squared. So the GCF is 4x squared. Now if that doesn't make sense to you, I can go through a more detailed explanation. I'm going to factor the absolute value of each term in the polynomial. For the first term, 20x to the fifth factors as 2 times 2 times 5 times x to the fifth. 8x to the fourth factors as 2 times 2 times 2 times x to the fourth. And 12x squared factors as 2 times 2 times 3 times x squared. From the factored forms, we see that each term has a pair of 2's as factors, and each term has x to the second power as factors. So the GCF is 2 times 2 times x squared, or simply 4x squared. In example 2, we have 18 a to the third b squared minus 24 a to the fourth bc. The GCF is 6a cubed b because 6 is the greatest number that divides evenly into 18 and 24. Furthermore, each term has up to 3 factors of a and 1 factor of b. In more detail, we can factor each term. The first term factors as 2 times 3 times 3 times a cubed b squared. The second term factors as 2 times 2 times 2 times 3 times a to the fourth times b times c. The common factors are 2, 3, a cubed, and b, giving us a GCF of 6a cubed b.
All right. So this is pretty easy here. We should be able to eyeball this stuff fairly easily. All right. First, look at the constants here. What's the biggest thing you can pull out of these three numbers? Right? 7. 7 divides into both of these. You can't pull anything bigger than 7 out of 7. All right? And the highest power of x here is x squared. So that's your GCF, right? Here you have a 15 and a 25. The biggest number that you can divide out of both of these would be a 5. You can't get a 10 or 15 or anything else. 5 is the biggest number that'll divide into both of those. Now look at your A's. The most A's you can get is a cubed, because you can't pull an a to the fourth out of there, right? So it's going to be your lowest power is the most that you can pull out of them. And then the B's, you only have one B. You can't get more than one B out of this one. So it's just 5a cubed B. And now all right, look at the constants. The biggest number you can pull out of these would be a 5. You can't get a 10 out of 15. It doesn't divide evenly. Okay, and 5 is already half a 10, so you can't go any bigger than that. Now look at your Z's. This one only has one Z. You can only get one Z out of it. You can't get more Z's than one. So that's it, 5Z. A 6 and a 21, the biggest number, let's see. 6 does not, let's see this, yeah, 6, no, 6 times 3 is 18. You can't get a 6 out of 21. They are both divisible by 3, however. All right, you can get a 3 out of 6, you can get a 3 out of 21. And now for the W's, the most you can get is 3 of them, right? Because that's the least power of W. And for the Y's, the most you're going to get is the Y squared. You can't get more than Y squared. All right, and the whole purpose of this is we want to, if these were added together, we want to be able to write this as 5Z times a 2Z squared. See, this would give me 10Z cubed. And then to get the 15, I'd have to multiply the 5 times a 3. To get a Z to the 5th, I need Z to the 4th. And then for the 40, I'd have to multiply the, the 5 times an 8. 8 times 5 is 40, and Z. So the purpose of the GCF is to factor. All right, here's your GCF. And if these things were added together, there's your 10Z cubed. There's your 15Z to the 5th. And then your 40 z. So like if these were added together, we would want to get the GCF out, and we'd have to multiply this by a 2y cubed. So that gives me the 6. I got the w cubed, and the y squared times the y cubed gives me a y to the 5th. And then to get this guy, I need to multiply 3 times 7 times 3 is 21. To get a y to the 4th out of the cubed, I need another y. And then the y squared, I'd already have the y squared. So that's the point of the GCF here, is to start factoring. When you look at that, you're looking at what's the biggest thing I can factor out. In this case, it's a 5 and a z. What's the GCF of these? Let's see, the biggest number that'll come out of 8 and 6 is 2. The most C's I can get is 2 of them. I can't get C cubed out of this. There's only 2 of them. The D's, the most I'm going to get is 4. I can't get 5 out of this guy. Then we got E's. This one doesn't have any E's, so I can't get any E's out of both of them. Okay. So if I had 8c squared d to the 7th e plus 6c cubed d to the 4th, I could rewrite this as 2c squared d to the 4th times, in order to get that from this, I need to have a 4. 4 times 2 is 8. There's a c squared. I already got c squared. There's a d to the 7th. I have 4 of them. I'd need 3 more. And then I'd need an e. That would give me this term. And now to get this from this guy, I need to multiply this by a 3. 3 times 2 is 6. I have c squared, but I need c cubed, so I need another c. That gives me the c cubed. And I already have the d to the 4th, so I don't need to put any d's here, right? 8 c squared d to the 5th e. I'm sorry, d to the 7th. 3 and 4 make 7. And then 6 c cubed d to the 4th. Another one here. So if I had 9m squared n p to the 8th plus 15 n to the 4th p to the 5th, what can I factor out? The biggest number I can pull out of both of these is a 3, right? And I need a 3 times 3 to get a 9, and a 3 times 5 to give me the 15, right? What about m's? Right, this one doesn't have any m's, so I can't factor an m out. How about n's? This one has 1. I can collect 1 from each of these. And now the p's, they both have at least 5, right? So for this first term, I get a 3 times 3 gives me a 9. I need an m squared. There's no m's. I need an n, and I have an n. I need a p to the 8th. I only have 5 of them, so I need 3 more. So this times this gives me this guy. Now what about this one here? The 3 times the 5 gives me the 15. I need n to the 4th, but I only have n. So I need 3 more. And now p's. I need p to the 5th. Well, I have p to the 5th. So that's it. 15, n to the 4th, p to the 5th.
In this video, we have 3x times the quantity 2y plus 7 minus 4 times the quantity 2y plus greatest common factor? Well, first note that we have only two terms here, and the common factor is the binomial within parentheses 2y plus 7. So by inspection, we see that GCF is the quantity 2y plus 7.
Okay. So this is the same thing. It's just the name of the number has gotten longer. Both of these have an a plus b. If I had 3x times a plus b plus 2y times a plus b, I could say both of these have an a plus b. I have a 3x and I have a 2y, and they're both being multiplied by an a plus b, right? That's the goal, right? They both have an a plus b that you can factor out. Here, if I change this to a plus, if I was adding these, I have an a and I have a b, and they're both being multiplied by x plus 2.
In this video, we want to factor out the GCF of the polynomial 20x to the fifth minus 8x to the fourth plus 12x squared. Now, in a previous video, we determined the GCF to be 4x squared. Factoring out the GCF of a polynomial is reversing the process to multiply polynomials using the distributive property. In other words, we want to find a product of the GCF, which is 4x squared, and another polynomial that, when multiplied, equals the original polynomial. I'll use an empty set of parentheses as a placeholder. So I want to have three terms inside the parentheses that, when multiplied by 4x squared, gives me 20x to the fifth minus 8x to the fourth plus 12x squared. So the quick explanation is to ask, 4x squared times what will give me 20x to the fifth? The answer is 5x cubed. So that becomes the first term in the parentheses. Next, 4x squared times what will give us negative 8x to the fourth? The answer is negative 2x squared. This becomes the second term in parentheses. Finally, 4x squared times what will give us 12x squared? The answer is 3, which becomes the third term in parentheses. So this is the factored form of the polynomial. Now I want to mention that all factoring problems can be checked using multiplication. I have 4x squared times 5x cubed is 20x to the fifth. 4x squared times negative 2x squared is negative 8x to the fourth. And 4x squared times 3 is 12x squared. Now, if you had any trouble following how I got the three terms within parentheses, I'll go into more detail here. Each term within parentheses can be found by dividing the original term by the GCF. So if I take 20x to the fifth and divide it by 4x squared, we get 5x cubed, which is our first term in parentheses. Next, if I take negative 8x to the fourth, divided by the GCF, 4x squared, we have negative 2x squared, which is the second term within parentheses. Finally, if I divide 12x squared by 4x squared, we have 3, which is the third term in parentheses.
Let's see, halfway through this thing. let's call it a day and have a exam here. Daily exam 19. Let's see. We'll do long division. All right. Long divide. All right, let's do number one. Let's do x cubed plus 2x plus 3 divided by x minus 1. And let's do 2x to the fourth plus 3x squared minus 4 divided by x squared plus 1. And that'll be it for today, folks.